Okay, so at this point in the book, I've walked you through some examples of how to put your prediction online. However, even though I've shown you how to pull your data from a live SQL database, we need to walk through a few automated processes for cleaning and pre-processing the data. Because before this point, when we were just working with a CSV file from Excel, it was very easy to go into Excel first and do whatever reformatting and cleaning we wanted to before pulling the data set into Azure. However, if you want to use this in an actual machine learning environment that's automated, then what we need to do is use the tools that Azure has for us to perform all of the typical processes that would be performed in an ETL automatically in Azure. So I'm going to show you a few of these, definitely not all of them, but some good examples over the next few videos. So to do this, I'm going to switch. We've been using the bike buyers data, but instead I want to switch to using the lending tree data, which if you haven't been following along, if you're just watching this from YouTube, lending tree puts out a free data set to Kaggle that they update it regularly with loans that have been given out and the current status of loans, whether it's been fully paid, charged off, default, late, current, issued, all these different statuses. So I've taken that and put it into a SQL database just so that we can keep living in a live environment here. So if you aren't in my class and don't have this password I've given out to the class, I will add a link to the CSV file so that you can still follow along in the video. So database server name, if you remember from class, let's see, this is is415.database.windows.net. is415 is the database name. I also made that the username, and then a password, which I've shared in other videos or in class that you're welcome to use. So our query here, I'm going to say select all from, the table is called LC_loans, and let's just say order by, let's see, now I can't remember. Here's the table. Let's see what we got. I think it's ID. Yep. Okay, yep, ID. So let's do this because I want the most recent loans and I don't want to have to pull the entire, I've got over 800,000 records in here. Let's sort by ID descending and let's get the top 50 to keep it simple. So I'm going to say order by ID descending, and let's also change this to just the top 50,000. That should be good enough. Okay, so I'm also going to use cache results so we don't have to keep pulling it from the database repeatedly. So I'm going to run this and pause the video until it's done. Alright, let's take a look and see what we've got here. Oh yeah, that does it sometimes. Alright, I'll show you the data in just a second. Let's pull in another pill first. So the one I want next is called, so let's say with our 50,000 records, we find that even that's too many and it's taking way too long to process. So let's take that down to only 20,000 records to save ourselves some time. So that's what we'll use the partition and sample pill for. Pull that in. Let's take a look at our options. So first of all, sampling is pretty straightforward. It just says what % of the data set do you want back. And random seed, if you leave that at 0, it'll always grab a different random sample. To keep things consistent, I'm just going to put in the 1, 2, 3, 4, 5. Stratified. Now this is quite useful if you have a proportion of your dependent variable or label that you want to keep consistent with your new sample. So for example, in this, the dependent label is going to be the loan status. Are they current, default, what's their status? Let's say that I care a lot about maintaining the current proportion of each of those values. Now in this particular data set, those values are very out of proportion because the vast majority of them are fully paid because they're older loans. However, I did grab a more recent poll of 50,000 of the last 50,000, so maybe those are not actually finished, and I've got a nicer spread of current, default, late, fully paid, and all that. So by saying stratified true, what this does is it says pick a variable and tell me which one you want to stratify based on. So if I launch the column selector, almost every time what we're going to want is the dependent variable or the label. So I grab loan status, pull that in, and it's going to look at the current ratio or proportion of all the records that are each of the 7 loan statuses that are found in the data set. And when it grabs its random sample, it's going to make sure it keeps that proportion the same. So let's up this though. I want more than 1%. I've got 50,000. Let's take it down to 20,000, which means I want 0.4. Whoops, 2 points. There we go. So let's run that. I'll pause it here while we're waiting. Okay, so that took only a second. Let's take a look at our output data set here. Visualize. So, yep, sure enough, we only have 20,000 records left. I can scroll through and see I still have all the data I selected originally. But there's some other issues we're going to need to worry about with cleaning. So we'll come to those in a minute. For now, I just want to finish this particular pill and show you the other options. So assign to folds, what this does is we can say, okay, let's say we want 5 or 10 folds is pretty common. That means let's divide the data set up into 10 even groups, and we'll randomly decide which to put in there. This says keep them even. This one lets us pick, we can put a list based on commas of customized proportions for each value. Here, same issue, same option, stratified or not. Assign to folds is useful for preventing overfitting, but we'll save that topic for another day. Head means it's a lot like in SQL when I use the grab top 50,000 technique. This just means grab the top and you can determine how many rows you want right there. So that one can be done either there or in the SQL. So I'm going to stick with my original sampling though, and let's stop this video and move on to another pill that could be useful.